All right, so hey everyone again. Today is the last type of polar graph that we're going to look at in detail. So our aim is how do we graph roses? Okay. Roses have an equation of the form like a cosine n theta and a sine n theta, as we'll see in the notes. And do now is just complete the following table right here from 0 to 2 pi for this function, cosine 2 theta. And then we're going to graph, as we did yesterday for the lemmastones and cardioids, graph this function on a rectangular grid. All right, so yeah, don't worry if you didn't complete this yet. I'm going to go through the solution. I'm going to scroll up for that. Okay. All right, so here it is. Here's the table. So yeah, actually the table actually just turns out to be like 1, 0, -1, just alternating, right? Just as a sample, like if you plug in 0, you get cosine of 0, right? Cosine 0 is 1, so that's why you have that first value there of 1. Next, we have pi over 4, so cosine of 2 times pi over 4 is cosine of pi over 2. Cosine pi over 2 is 0. And then as another example, like if you plug in pi over 2, you get cosine of 2 times pi over 2, which is cosine pi, which is -1, right? And then you do the same thing for the rest of the values. You get, 0, 1, 0, -1, 0, 1. From there, we would plot the points on the rectangular grid. So you would get these points, right? So yeah, 0, 1 is here, followed by pi over 4, 0, followed by pi over 2, -1, then 3 pi over 4, 0, pi 1, etc. Oh, whoops, that middle point is wrong. This one right here. This should be pi over 2, -1 right here. But yeah, next we're going to plot this on a polar grid. So just like we did yesterday, we're going to analyze the intervals and see how the R value changes as theta changes, and then translate that to a polar grid. But yeah, for now, just please make sure you have this, both the table and this graph in your notes. All right. Is anyone still copying this down? You can either type in the chat or speak up. All right. If not, then I'll move on. Okay, here we are. So the following exercise is just graph R equals cosine 2 theta, the same function from the do now on a polar grid from 0 to 2 pi. All right, so I just copied the rectangular graph here also. Points to plot, I just chose, technically you could choose like more than these, but I chose these points. These are the ones from the textbook. Okay, so you have like 1, 0. And again, these points come from the table, right? So like, all these points are in R theta. So I'll write that just to make it extra clear. All these points are in the form of R theta. So these are polar coordinate points, right? These came from this table, right? So 1, 0. Next we have -1 pi over 2. This one. 1 pi, that's right here, right? So to plot that on the polar grid, for example, like 1, 0 is right here. Next we have -1, which starts on the left, then pi over 2, which is here. 1 pi, so 1, and then rotate pi is here. And then -1, 3 pi over 2. So -1, and then rotate 270 degrees counterclockwise. You end up right here. Okay. And then 1, 2 pi is the same as this location. Okay. But yeah, those are your 4 points that we know of that are on the graph. And then from here, we're gonna, do the same thing we did yesterday. We're gonna analyze the intervals. So this is just all information that we extracted from this rectangular graph right here, right? So for example, like the first interval is from 0 to 4 pi, right? That's 0 to 4 pi. It's right here. So it says R is positive, and yesterday we didn't really designate whether it's positive or negative, but today we're going to identify it because at least for this graph, it is important. So yeah, just keep that in mind. That's something that we have to be aware of. R is positive, so it's starts from +1 and decreases to 0, right? So again, R is positive from 0 to 45 degrees and decreases from a value of 1 to a value of 0. Okay, so what that means for our polar graph is, from 0 to 45 degrees, that's this portion right here, right? It decreases from 1 to 0. So we're going to start here and then spiral inward towards 0. Okay, so that's actually how you get this loop right here. Draw that better. Yeah, so something like that, right? And this is, these numbers are from the textbook. Okay, so like this is the first interval. As you'll notice, the interval 2 is actually right here, which I'll explain why that is. And then you have interval 6, 7, 4, 5, 3, and 8, right? Okay. See if I can do that. Right. Yeah, I'll leave that as is. Next we have interval 2, which is R is negative. So that comes from this part, right? So R is negative. So it's negative here, right? From pi over 4 to pi over 2. So 45 degrees to 90 degrees, and decreases from 0 to -1. Okay, so this is the interval that we're analyzing. How that translates to the graph is, so since R is negative, we're going to start on the left side of the polar axis and then rotate 45 to 90 degrees. So 45 degrees is going to place us right here in this sector, and then to 90 degrees, and decreases from 0 to -1. So don't be caught up in the word decreases. That just keep in mind that it goes from 0, so which is the pole, the origin, to -1, right? And since we're negative, we start on the left, right? So we're actually going to spiral outwards for this second interval right here, interval number 2. Okay, let me do one more, and then I'll leave it at that. So R is negative. That's interval 3, from pi over 2 to 3 pi over 4. That's this one right here, right? 90 degrees to 135, and increases from -1 to 0, right? -1 to 0. How that translates to our polar graph is, R is negative, so start on the left side of the polar axis, rotate 90 to 135. So 90 degrees is over here, then 135, that's right here, and increases from -1 to 0. So we're going to spiral inwards, right? So we start at -1, which is here, and then spiral inwards towards 0, right there. Okay. But yeah, you would do the same thing for the rest of the intervals, and then you would get this rose shape. Okay. Well, for the sake of your notes, just please make sure you have, please do copy down the intervals. You don't have to copy down the rectangular grid again, but also please do have a sketch of the rows. All right. Does anyone still need this or have any questions on this? No? Okay. So now that I'll move on. Okay, next is the notes or summarizing roses. Okay, that was, yeah, up there is the example. But yeah, can someone read this slide for us right here?
The roses. The graph of an equation of the form r equals a cosine n theta, or r equals a sine n theta, is an n-leaved rose if n is odd, or a 2n leaved rose if n is even. For example, r equals cosine 2 theta has 4 leaves.
All right, thank you for that. So yeah, cosine 2 theta, or r equals cosine 2 theta, is the function that we saw in the do now. and that's the one we just graphed, right? So as you saw it as 4 loops, right? So 4 leaves. And yeah, just notice that the form of this function of arrows is like really similar to the function for circles, right? So like a few lessons ago, we saw circles with centers on the axes. That was like a cosine theta, a sine theta, right? But if you had an n coefficient here in front of theta, right, graphically that changes the period, right? If you think back to, you know, when we're graphing sine and cosine, right, that would be like 2 pi divided by n, right? That's the period. In polar form, though, that changes the circle to a rose. Okay. And yeah, so hopefully, well, let me ask you, does anyone actually enjoy polar graphs? Like, I don't know, like some people find it confusing in years past. Some people actually like, you know, like graphing these. KV says no. We got a nah from Rahib and interesting from Oscar. Okay. Confusing. Okay. Yeah. Yeah. I actually remember when I was first learning this at Mystery High School. It was confusing. And personally, it's actually not on a personal note, it's not my favorite unit, but you know, yeah, I'm still teaching it because it's in the curriculum. Anyways, but you know, hopefully through this unit you saw the purpose of polar graphs. You know, some graphs like this, like the rose, it's more, you know, naturally derived through polar coordinates, right? Okay, with that being said, does anyone still need this slide here? Okay, not, oh, well, to answer Meryl's question, why is there another system? So actually, it actually comes up in, well, I know one particular application is calculus. There might be more. I know there are, but I just haven't come across them. But in calculus, you actually come across integrals. So that's like the second half of calculus that are more easily computed using polar coordinates. So like, you know, if you remember from like the polar equation, rectangular equation lesson, like some equations can be better or more easily written using polar coordinates. So sometimes we use the polar form of an equation to take the integral in calculus. You'll see that when we take multivariable calculus. Okay. Yeah, this is important. It's just like, I know it's not as intuitive as the Cartesian plane, but yes, there are, you know, uses, necessary uses for this system. Okay. Okay, let me get to the classwork. Okay. Yeah, actually, I'll just go ahead and go through it with you. So yeah, instead of like, yeah, just instead of having you work on your own, I'll just go through it together as a class. So the question here is graph r equals 4 sine 3 theta on a rectangular grid from 0 to pi, and then translate the points to a polar grid. Now to save time, instead of making a table, just use your graph calculator, and I specify the, you know, the windows here. So x min is 0, x max is pi, the x scale is pi over 6, y min is -10, y max is 10. But yeah, if you do that on your graph calculator, you will get this graph right here. So yeah, points to note would be like 0, 0. There's also a point at pi over 6, 4, pi over 3, 0, pi over 2, -4, 2 pi over 3, 0. So that would be 1 period, and then yeah, 5 pi over 6, 4, and then pi 0. Okay, so that's what your graph will look like for this rose curve, okay, in rectangular form. Now, to translate that to polar form, right, we're going to plot these points. So I chose these 3 points in particular because these actually make up the ends of the leaves, so to speak, on the rose curve. And actually, let me scroll down. Okay, so yeah, the points to plot are 4 pi over 6, which is here. All right, so radius of 4, pi over 6. Next, we have -4 pi over 2. So -4 is on the left, rotate pi over 2 counterclockwise. That's right here. And then 4, 5 pi over 6. So 4 is on the right, and then rotate 150 degrees. We end up right here. Okay. Now to draw the rest of the rose curve, we're going to analyze this graph here. Right. So first interval is r is positive from 0 to pi over 6. So that's right here. Right, it's positive and increases from 0 to 4. Okay, so we're going to spiral outwards. So from 0, spiral outwards to 4. Okay. Next, we have r is positive from pi over 6 to pi over 3. So positive we saw on the right here, and then 30 degrees to 6 degrees, and decreases from 4 to 0. Okay, so that's like this pi over 3 to pi over, that's like this sector right here. So that'll be like 4 to 0. That spirals inwards towards the pole. Next, we have r is negative from pi over 3 to pi over 2. So that'll be like right here, right? It's a negative r value, and decreases from 0 to -4. Okay, so r is negative. We start on the left and then rotate 60 to 90. So 60 to 90 is like this sector right here. Decreases from 0 to -4, so we spiral outwards. Okay. Yeah, but yeah, you guys get the idea. For the remaining intervals, we would come with the remaining portions of the rows. Okay. Okay, let me clear the drawing so you can see that. Yeah, that's what your rose curve of 4 sine 3 theta would look like. Let me zoom out. All right, does anyone still need to copy this? All right, if not, then I'll just want to mention 2 other things and then we'll close. So on the homework, I actually included a summary that was provided from the old textbook. Now you'll see this in the homework assignment on Google Classroom, but just want to mention, good resource, good summary to think about, what we've learned so far. So here we have circles in the first row. Next we have limastones, and then, we saw that a cardioid is a special case of a limastone. That's what we talked about yesterday. And then today we talked about roses. Okay. Lemniscates, we're not really going to look at that in detail. But yeah, that's another type of polar graph that that occurs, right? But yeah, just want to give this a shout out. It's on the homework assignment. All right, last thing I wanted to say was, let me go through some homework questions. The one due tonight is homework 46. Okay. Now, this is the limasomes and cardioids one. So as you can see from the first one, I did make a table of values. Now, as I said yesterday, feel free to use Desmos to check, but I do expect you to be able to just evaluate these tables, right? Now, not saying that that's difficult or anything, because we've already done that in the trig unit. But yeah, just be able to dissect this notation, right? We have r theta, right? R is the dependent variable, right? But it comes first in r theta. But yeah, these are the values you get for the first question. I plotted these 5 points, and then I made use of the fact that it's symmetric about the x-axis, which we briefly talked about yesterday. And then I draw the rest of the curve. But yeah, I use Desmos to check my work. So yeah, just feel free to definitely use that as a resource. Okay. And then yeah, you can see the same thing for 24 and 34. Okay. All right, but yeah, in closing, for announcements, there is SGI today, per usual, 2:47. Secondly, reminder that our next quiz will be the Friday after we come back from break. Third, I think I said this yesterday, but there's going to be a group project in place of the mid-year exam. So I will send out instructions about that over the break. But yeah, that'll be due like you'll have until the end of the semester to finish that, and that will replace your lowest quiz grade. Okay. But yeah, more details to follow. Just have to think through some details about the group project. So, but yeah, all that being said, hope you have a great break, and I will see you all in the next year. All right, take care.
Thank you. Bye. Have a good break.
Thank you.
All right, thank you. You
Have a
too.
nice break.
Thank you.
Have a
Thank you
nice
so much,
break.
Yang.
Thanks. You too. Thanks.
Take care.